A seclusion room is an area of the emergency department where patients are put because there's an acute behavioral issue. Either they're a danger to themselves or they're a danger to others. The main characteristics of these seclusion rooms is they're pretty bare bones. There's nothing that could be movable, that could be taken off the wall or the floor, just basically a mattress, a sink, and a toilet. You can't have any wired continuous monitoring of a patient because those wires represent a potential danger for the patient. The only other way of observing the patient is through the camera that's in the corner of the room. That's fine if the patient is up and around and walking. You know that the patient's alert, they've got a heart rate, they've got a pulse. But the problem is when they're sleeping, you don't really know what's happening. There could be minimal chest movement, so you're not really sure if they're actually asleep or they're dead.
Our solution is the InSight, a radar-based patient monitoring system made for seclusion rooms. It is self-contained, using a Raspberry Pi to process the data from an Infineon radar module. The InSight works by transmitting radar chirps, which reflect off the patient. By observing the subtle changes in the delay between the transmitted and reflected chirps, we can measure the movement of the patient's chest with sub-millimeter precision, which allows us to extract the breathing and heartbeat signals. Hospital staff can see patient vital rates on our user-friendly GUI. They can monitor multiple patients, see details of a specific patient, adjust the alert settings, and view each patient's past records. When a patient's vitals are abnormal, an alert appears on screen and an alarm sounds. This lets medical staff know that a patient may be in danger. The InSight reduces the uncertainty caused by the lack of patient monitoring. It allows medical staff to accurately monitor multiple patients in real time and raises alerts when abnormal vital conditions are detected. This results in faster response times, allowing staff to provide medical care more effectively, and ultimately helps to prevent the deaths of vulnerable patients.
There is significant morbidity and mortality that happens every year, and this is a potential way of addressing that in a real-life scenario.